Okay, in this video we're going to talk about how to solve some dynamic financial problems using the Excel solver. Our file is FinMath solver template or temp. Okay, so you remember back we talked about the PMT function to figure out what the monthly payment is on a loan or quarterly or annual payment, whatever. Okay, so the example we used was you're borrowing $1,000 for 10 months, end of the month payments, and the monthly payment was $1,037. Okay, now we did that with PMT function. We could probably do it with GoalSeek, but let's do it with Solver. And the key thing to understand is your ending balance will equal the beginning balance on the loan. Okay, and then you'd subtract off your payment minus the amount of payment that goes to interest. Okay, so let's think about target cell, changing cell, and constraints. Target cell is the monthly payment. What should you pay? That's also the changing cell. There's no law against that. Whatever you pay every month is also the changing cell. And you want to minimize the monthly payment. Let's say it doesn't really matter. And the constraint is the ending month T balance equals 0. Okay, so we got to just keep track of, let's make up a payment. Let's suppose we pay $1,200 every month. Okay, so that's going to be the changing cell and the target cell. And we'll just assume every month, I gave that a range name payment, I believe. See, if you go to the range name payment, it's right there. And then the rate, the rate that we're using in this loan is 8% divided by 12. We need a monthly rate. And I name that cell rate. Okay. So all I have to do is copy that down there. Sorry, the basically monthly payment is that cell. And just say equals whatever's in there. Drag it down. So every month we pay the same amount, although the only changing cell is in C5. Now what do we owe in interest? Well, we owe the rate times the beginning balance. What I forgot to say, beginning month T plus 1 balance equals end month T balance. So the ending balance would be what the starting balance was, take away what your payment was, minus what goes to interest. Okay. So we now owe $86.67. Now what's the beginning month 2 balance? It's the ending month 1 balance. Drag that down. Drag the interest down, drag the ending balance down. Okay, so now you see we paid too much because we ended up with an ending balance of minus 1679. We need E14 equals 0. And it's a linear model because we're just multiplying changing cells by constants added together. So what we would do is we would minimize the monthly payment. We'll change the monthly payment. And we'll add a constraint that the ending balance equals 0 and the monthly payment must be non-negative. And we should get our friendly answer. There's our 1037.03. And if I try that PMT function, we know this, but let's try it. 0.08 divided by 12. We got 10 months. Present value is 10,000. No future value in end of month payments. We get the right answer. Okay, now let's go to a retirement planning problem. Let's suppose you're going to start saving for retirement in year 1. And then every year through year 40, and let's unhide some of these rows here. If I do right click, think I've got a button for unhide rows. Let's see. Yes. Okay. Selected the whole worksheet, and then I put on the quick access toolbar unhide rows. Okay, so every year 1 through 40, our contribution will go at $500 a year. So all I've got to do is figure out what I'm going to contribute during the first year. That's my changing cell, and that'll be my target cell. And I'll increase the contribution $500 a year. Okay. And we'll assume I earn 10% of my money the first 40 years. I'll earn 5% after, the first 20 years, 5% the remaining time, and I'm going to live for 20 years. I hate to know how long I'm going to live, to be honest. But for 20 years, I will try and withdraw $100,000 a year. What should I put in during year one? Well, let's think about target cell is the year one contribution. The changing cells are, what would they be? The changing cell would simply be the year one contribution. And I want to minimize that. You can maximize it, it doesn't really matter. And the constraint is at the end of year 60, I've got no money left. Okay. Now, what do you have at the end of year T? You've got what you began year T, plus the contribution. This is for the first 40, well, in general, you have what you begin with, plus the contribution, and you multiply by 1 plus rate of return. And then you would subtract off the withdrawal if there's any. So I'm assuming I get that return at the beginning of the year. And then you begin year T plus 1 with the end year T balance. Okay, so let's give this a shot here. So that's what I put in. Okay, I'm withdrawing nothing the first 40 years. I've got the last 20 years. So what I would end year one with would be the initial balance, which I assume is 0, plus that contribution times 1 plus the rate. There's no withdrawal. Okay. Now the contribution every year will go up $500, okay, we're going to say for 40 years here. So I'll take this contribution plus 500, and that's going to go through year 40. We're going to increase it as we make more money, hopefully, through our working life. Okay. Now, the ending balance, I should just be able to copy down if I've got this right. And the beginning balance, oops, you don't want to copy 0 down. You want to copy last year's ending balance. Okay. Okay. I think the way I set this up, and was a little bit different, okay, that basically we're going to withdraw the money at the beginning of the year, okay, and then we'll get 1 plus the interest rate. It's a matter of timing. So let's assume that way, because in my textbook, I think that's the way we have it set up. Okay, that's right. So sorry about that. So our end of year T, okay, and there's nothing wrong with the way I had it there. I'm going to assume you take away the withdrawal at the beginning of the year, and then you get 1 plus the rate of return. So you begin the year with some money, you add the contribution, and then you subtract off the withdrawal, and then you get the rate of return. Rather than assume the withdrawal, if the withdrawal is the end of the year, it changes the problem a lot. And since I have a textbook that solves it this way, let's leave it this way. All right, so 1387 does work out, you can see, because you end with a balance of 0 here. But let's change it to, let's suppose you put in 2,000 in year 1, 500 every year, you'd end up with a lot of money in the bank, the power of compound interest. But all I have to do is go solver. I want to minimize the contribution. I want to change the contribution. And I want to add that the ending balance is 0. Okay. And there you go. You put $1,388 in the first year, add 500 every year till the 40th year, and then you just start taking the money out. Okay, but you take out 100,000, you'd go here from, let's say, 1,300,000 down to 1,200,000, then you'd earn 5% on it. So I'm assuming at the beginning of the year. I think we have that right. Beginning of the year. I should have made that clear. Okay, so that concludes our discussion of linear solver models. We'll start with a few nonlinear models, although I think we'll have to add some more advanced videos on nonlinear models later on. But we'll have 3 topics. We'll talk about rating sports teams, locating a warehouse, and we'll also talk about a simple pricing model using the Excel trend curve, which we studied earlier.